All right, here we're going to look at example number 22 on page 6 and the two discussion questions on that same page as well in this video. So the first one here, we have this motorcycle police officer. And they're traveling on our graph, and the graph is on the packet, so make sure you look at that graph. Here's just a sketch of it. And it wants to know what's the acceleration at 3 seconds, at the 7-second mark, and then over here at the 11-second mark. And since this is a velocity versus time graph and they want us to find the acceleration, we're actually looking for the slope at each one of those points. All right, so in order to find slope, you do need to have 2 points to find a slope. Nice thing about 3 seconds is, what's the slope at 3 seconds? 0, yeah. The 7-second one, okay, so now I gotta pick 2 points on this line, and I'll look closely at that picture on your packet. And what you're gonna see is there's not any 2 good points that actually goes through one of those crosshairs. Those are the points you really like to use. You like to use those ones that go right through those crosshairs exactly. So I might go, well, I'll do my best. So I looked and I said, well, at 9 seconds, it looks like it's at about 43 meters per second. And at 6 seconds, it looks like it's about 24 meters per second. Now notice I'm using about, and that kind of brings up a point here. For us, we can see the police officer is moving at a constant speed. They all of a sudden speed up and then slow down. So this graph is pretty good at describing that motion for us. Not that great at getting us numbers because it just so happens that we don't have specific points on there to help us find those slopes. So with these first sets of data points, I actually end up with 6.3 meters per second. Now you might have looked at this and said, you know what, I see a different point that I wanted to use. Maybe you used the 8 seconds and you said 37, or maybe you looked at these and you said, no, that's more like 44, Mr. Foster. Okay, there's going to be some discrepancy. There's going to be some uncertainty in those values because of this graph we're using. So it's not that we can't use graphs to describe motion. It's just they're not always that accurate at giving us numbers if we want to find things like maybe slope. This one comes out to be 6.5 meters per second. So depending on the points you pick, you might get some roughly different numbers. That's why when we try to find exact numbers for something like this, it's better for us to have equations for these lines to put together. Okay. I want you guys to go ahead, hit pause on the video and try and find the velocity here, the acceleration here at 11 seconds. All right, so you tried to find that acceleration here at 11 seconds. So what'd you get? So some values that came for me were, I got something like negative 10.5 and maybe up as high as like 12 meters per second squared as our accelerations there. I forgot the squares over here. Gold card for anyone that noticed that. All right, so yeah, hopefully you landed somewhere in that range. Again, make sure you have those negative signs denoting the fact that that slope is downward and you were subtracting the correct things. Final velocity minus initial velocity kind of stuff when you're finding your slope. All right, let's move over to these discussion questions next. So for these discussion questions, again, I'd like you to read through them, try and answer them, and then come back to the video and see the explanation. All right, so the first one says, is it possible that I could have a car moving north but accelerating south? Is that possible that my velocity and acceleration could be in opposite directions? And if so, give me an example. Well, whenever your velocity and your acceleration are in opposite directions, that just means you're slowing down. So whenever you see velocity and acceleration in opposite directions, slowing down, same direction, speeding up. And so in this case, my car would be traveling north, but maybe coming to a stop sign would be an example. Discussion number 6 says, is it possible for something to be stopped but accelerating? Now, some people read this one wrong, that it's like when you say stopped, it means you're just forever stopped. Excuse me. Stopped here means you're just momentarily stopped. At an instant, you are stopped. So for instance, in order to start moving, you start stopped, and in order to start moving, you need to accelerate. So that would be a great example. The example I'm going to show you here is if you throw the ball up in the air, the ball has a positive velocity and then the velocity switches to a negative. And what number do you got to go through if you go from positive numbers to negative numbers? You got to go through 0, meaning for a moment there, it is stopped. Let me use the green here. So my velocity starts at a positive value. When I throw it up, the acceleration is negative. So I have a negative slope because acceleration of gravity is down. And at this moment here, the velocity is 0 and the line has a slope, meaning the velocity is 0 and there's an acceleration. Now, is it going to stay stopped for long? No, it's only for an instant that that ball comes to a stop up there at the maximum height.